Okay, so for this part of Sec 2 algebra, we are focusing on the graph of quadratic function. Okay, so I'm going to start off first with the properties of quadratic function first. Okay, so the property are standard things that doesn't change. So as long as it's a quadratic function, the property will follow. So when you go Sec 3, you will still be handling quadratic function. So it will be the same property all over again. Okay, so one of the first property, okay, will be, okay, quadratic function will surely look like this. It will be ax squared plus bx plus c. So it's a standard feature. So how if you see something like this, it will always be known as a quadratic function. Okay, so when you go Sec 3 in E math and A math, you will be dealing with like 2-3 chapters just dealing with quadratic function. Okay, so one of the condition will be the coefficient of x squared cannot be 0. That means, right, this part cannot be a 0. The moment if your coefficient of x squared is a 0, you will be left with a linear function. So if it's a 0x squared, you will not be getting a quadratic function. So this will be a linear function. So that is one of the important things. So the coefficient of x squared cannot be 0. If it's if the coefficient is 0, then you are not dealing with quadratic function anymore. Okay, and then there's only two shapes for the quadratic graph, and the shapes is actually decided by the coefficient. So this is a very important person. So this person will decide the shape. So if A is a positive number, so if A is a positive number, something like A equal to 1, 2, 3, or it can be even fraction, it doesn't matter. So as long as A is a positive number, it will be a small graph that comes with a minimum point. So if A is a negative number, so for example, A can be -1, -2, -3, okay, or it can be a fraction. Okay, it doesn't matter. Then it will be a set phase graph. So it will be a set phase graph, which is like a maximum graph with a maximum point. So there's only these two shapes. But sometimes there are students, even at Sec 3 or Sec 4, they cannot make up when will they be having a small phase, when will be having a set phase. So all these are standard feature. So you must get the standard feature in your head. Okay, so it will carry you until upper set. Okay, so this will be one of the important property. When will you see a minimum graph with a minimum point? So when A is positive, this is a minimum graph. Or sometimes we call it a small graph. Okay, if A is a negative value, okay, it will be a maximum graph. So sometimes we call it a set phase graph. So there's only two shapes. It's really not very confusing. When will you have a small graph and when will you have a set phase graph? Okay, so that will be one of the important things. Okay, now point number 3, maybe to some of for all of you at Sec 3, Sec 2, you might not seem important, but okay, it will be good if you have the idea that the graph will cut the x-axis at 0 point, 1 point, or 2 points. So the graph can cut the x-axis at 1 point, 2 point, or 0 point, 1 point, or 2 point. It will not cut at 3 point. it will only cut at 3 points where you have a cubic function. So you will be handling cubic function in upper set A math. So it will not be happening in E math. Okay, so for example here, so I can have a smile graph, or a set phase graph. So do you realize this situation, right? It doesn't cut the x-axis at all. So this one is called zero roots. It doesn't cut at all. Okay, and then so how do you get one root? You will get one root if it looks something like this. I need to draw properly. So you will get one root if it touch the x-axis. So this is one root. Okay, so this is the situation where it will cut the x-axis at one value. Okay, maybe this one I got to draw like this. So for two roots, how does that look like? That means it cut the x-axis at 2 points. So it will be something like this. So this will be what we call the two roots. So it can either be a smile graph or it can be a set phase graph. Okay, so this one is a feature that you will be seeing over and over again, particularly when you go, if you in the upper side, if you do set 3 A math. Okay, now if let's say our quadratic function is the format of y equal to x squared. So what is the difference between y equal to x squared and the normal quadratic function? So if you compare this versus the quadratic that I mentioned just now, you realize that it doesn't have the coefficient of x, it doesn't have the constant term. So when it doesn't have the coefficient of x or the constant term, it will definitely pass through the origin. The origin is a 0, 0. So it will surely pass through the origin. So it will pass through the origin looking like this. So it will pass through the origin if let's say A is positive. So example, if A is positive, it's something like y equal to 2x squared. So it will pass through the origin here. But if A is negative, then you will be getting a set phase. So you will be getting a set phase if A is negative. So if it's a negative, A is negative, that means, for example, I can have a minus 3x squared. So it will pass through the origin, but it will be a set phase. Okay, and in this case, right, the line of symmetry is the y-axis. So the line of symmetry is the y-axis. So the equation of this is x equal to 0. So x equal to 0 is the line of symmetry. So it will be a very common question that they will ask you for the equation of the line of symmetry. So when they ask you for the equation, and it is a vertical line, it's always x equal to a value. So if the question asks you for equation of the line of symmetry, and you just gave me a 0, you will get no marks. So it doesn't serve the equation purpose. So the equation is the name. So the name will come with x. So if you cannot just be writing a 0, which a lot of people will do that, and then they lose the 1 mark for the line of symmetry. Okay, and then right, the numerical value will also decide how fat the graph is. Okay, so as a very simple example, I'm going to show this feature. I'm going to show this feature here. So I'm just going to, I will draw a small graph. So I will illustrate the idea of how A will affect the fatness. Okay, so I'm going to draw something like this. Okay, I'm going to draw something like this. Obviously, the red one is fatter than the green one. Okay. And the yellow one is even more fat. Okay, so what kind of equation am I expecting? Okay, so the smaller the numerical value of A, the fatter the graph is. So if let's say I'm going to call this is the fattest. Okay, so maybe this one is a 2x squared. A is 2. Then here maybe this one is like 1x squared. And then this one is a half x squared. So can you compare the value of A? A is 2, A is 1, A is half. A is half is the smallest. That's why the graph is the fattest. Okay, so that is one of the feature. So these are all the basic property. Okay, there will be some more basic property as we run through more questions. Okay, so I'm going to show you a typical question like example 1, where they will kind of sketch it for you already, and you're supposed to find the coordinate. So all these are standard feature, also standard method. So as long as you don't forget, it's actually a very standard method. Okay, so they gave us the equation. So they gave us the quadratic equation. If you arrange the equation, you will see that it's minus x squared minus 3x plus 10. If you observe the coefficient, it's a minus 1. And that's why you end up as a set face. Okay, so that's why you will see a set face in this question. Okay, then the graph cuts the y-axis at A. So they say that it cuts the y-axis at A. So A is known as the y-intercept. So the proper name is called y-intercept. And the property is it will be 0 something. Y-intercept will always have the property of x equal to 0. So that's the property of y-intercept. Okay, and then it will cut the x-axis at B and C. So the correct name for B and C will be called the x-intercept. You will still see this in your Sec 3 E-Math and A-Math. So the feature of x-intercept, the property of x-intercept will be, it will be something 0. So y will be equal to 0. So that's the property of x-intercept. So in fact, the Sec 3, when they learn this topic in E-Math or A-Math, they will keep using this term. So the property doesn't change. It can be x-intercept of a curve. It can be the x-intercept of a straight line. It can be x-intercept of any other curve that you are going to see in upper set. As long as it's x-intercept or any curve, the y-coordinate is 0. And as long as it's the y-intercept of any curve, the x is always a 0. So these are fixed property. It doesn't change. Okay, so we'll discuss the fixed property first. Then after that, we'll discuss the highest point. And the highest point will have a certain property as well. But the highest point and the lowest point of a quadratic graph have a fixed property. So for the coordinates of A, which is what we know as the y-intercept, the feature is x is equal to 0. So it's very simple. You just put in the x equal to 0 into your equation. And you get y equal to 10. So you answer the coordinate in a bracket format. So it will be a 0, 10. Okay. Okay, I'm going to squeeze my answer here and there. Okay, so for part B, B and C are the x-intercept. So the feature of x-intercept, like I mentioned, it will always be y equal to 0. So you use the equation and change out the y equal to 0. And when you change out the y equal to 0, you get a quadratic equation. You will get a quadratic equation where you're supposed to cross factorize. So do your typical cross factorize, set the bracket equal to 0. And you will get your two answers. So use your common sense to allocate which is B and which is C. So if you look carefully, B is on the negative side. So if it's on the negative side, then I expect that this one will be a -5. C is on the positive side, so I expect it to be 2, 0. So use your common sense to allocate them. It cannot be the other way around, because it's obviously on the negative side of the x-axis. So then you reply them. Okay, remember to answer them properly. Don't just leave it as a 2 and -5. You will get marks deducted, because that is not considered a coordinate. So x-intercept and y-intercept has a fixed property. So the property of x-intercept, y is always 0. The property of y-intercept, x is always equal to 0. So fixed property of y-intercept and x-intercept. So it's a very standard thing. Okay, the next one, D is the highest point. So highest point or lowest point, it is always symmetrical about. It's symmetrical. There is a symmetrical property. So for quadratic graph, it's always symmetrical. Symmetrical meaning this and this will always be symmetrical about the highest point or the lowest point. So how are you going to find that you will share the x-intercept? So if you want to find the highest point, you will share the x-intercept. So D is the maximum point. So in order to get the maximum point, you share the x-intercept. That means you share out these two values. So you share by adding them, and then you divide by 2. So you share by adding them, and then you divide by 2. So you get -1.5. And after you share, you get the x coordinate. You return it to the equation. The equation will guide you to get a numerical value. So you return it back to the equation. So you will get 12 1/4. So this will form the highest point. So this one will form the coordinate of the highest point. So you will get the coordinates of the highest point, which is -1.5, 12 1/4. And from here, you can tell the equation of the line of symmetry. The equation of the line of symmetry. That means what is this equation? So this equation will be x equal to -1.5. Because is going to cut this part at minus 1.5. So you must write x equal to minus 1.5. If you just write it as, so there are some students who will do like this. So they'll just write this. So you will get no mark. So the equation must come with either x or y. If you don't come with x or y, that one is just a number. So what is the equation of the line of symmetry? So that will be the equation. So these are the standard thing that they will be asking you. It can be a set phase graph, it can be a small phase graph. Okay, the last part E is not so standard. So if one bracket K lies on the graph, so one bracket K, so maybe one is here. So what is the value K? You got the equation, so you can always afford to calculate. So the last part, okay, 1K means X is equal to 1. Put it back into the equation. So the equation is going to help you to calculate. So you will get 6. So K is equal to 6. So all these are the standard procedure, the property of x-intercept, the property of y-intercept. Then the turning point, the maximum point or the minimum point is also known as the turning point. So they are the same thing. And then the equation of the line of symmetry. Okay, so I'm going to show you example 2 based on the same thing again. So based on the same idea one more time. So we gotten the equation. So these two are the x-intercept. C is the y-intercept. So again, let's go through the standard procedure. So A and B are x-intercept. So property of x-intercept, meaning y equal to 0. So replace the equation with y equal to 0. So when you replace the equation with y equal to 0, you end up with your quadratic function. So you will get two brackets. First bracket equal to 0. Then second bracket equal to 0. Once you get that, use a bit of logic to assign which one is A, which one is B. So A is on the negative side. So A should be minus 2, 0. And B is on the positive side. So that should be 4, 0. Okay, then after that, let's go for the y-intercept. The property of y-intercept, x is always 0. Okay, you substitute in x equal to 0. So the full coordinate will be 0 minus 8. Some people don't answer them in coordinate. The way they answer is very skimpy. Okay, so when they say coordinates, that means it's the bracket XY format. And then we talk about the minimum point here. So D is the minimum point. So minimum point will always have a symmetrical property. So it will always be symmetrical about the x-intercept. So because it will always be symmetrical about the x-intercept, you always share the two intercept. So you always share these two numbers. So when you go upper set, right, you're doing exactly the same thing. And then subsequently, the y coordinate, return it back to the equation. So return it back to the equation. You will get a minus 9. So D will be 1 bracket minus 9. and the equation of the line of symmetry. So the equation of the line of symmetry, that is a vertical line that cuts at 1. So the equation is x equal to 1. All these are the standard kind of question. So it will not change. The only thing that changes is the equation, but the property will not change. The property of x-intercept will always be y equal to 0. The property of y-intercept will always be x equal to 0. The property of minimum point or maximum point is always sharing the x-intercept. And then you return back to the equation. And vertical line will always be the line of symmetry. So because it's always a vertical line, so it should always be x equal to something. And usually it corresponds to the x coordinate of the lowest point or the highest point. Okay, so all these are standard things. You are still seeing the same question when you go to upper sec. Okay, so standard property, standard feature, okay, is something that you should remember. Okay, so you as long as you apply the same property, you shouldn't go wrong. So it cannot be such that I change the equation, you don't know how to do x-intercept, or you don't know how to do y-intercept. Okay, so these are standard procedure which you can get 100% correct.